Hi everyone. In this video, we're going to see about the COA Practicum number 3. The first program goes like when you run the program using immediate addressing, the operand value is already embedded uh, inside the set itself. This means the processor does not need to access memory separately to fetch the operand in the MATLAB simulation. This results in zero memory access, very minimal execution time using TIC and TOC, and classification as faster execution with less power consumption. Since no external memory lookup is required, latency is highly predictable. This predictability makes immediate addressing extremely suitable for real time systems where consistent and fast response time is critical. On the other hand, indirect addressing, the instruction contains the memory address where the operand is stored. The processor must inform one memory access to fetch the data from that address. In the MATLAB output, this results in a slightly higher execution time compared to immediate addressing and is categorized as moderate speed with more power consumption. Even though the difference in execution time may appear small in software stimulation, in real hardware system, memory access introduces noticeable delay. Therefore, direct addressing is slightly slower and consumes more power compared to immediate. In conclusion, addressing is more efficient and better suited for real-time applications due to zero memory deficiency, while direct addressing is useful when operands cannot be embedded directly but involves minor overhead. So, and then second question explains the in registered addressing, the operand is stored directly inside a CPU register since it is internal to the processor and do not require external memory access. The number of mem- memory access is zero. In the MATLAB program, this results is very low executive time and the classification as fast with less power consumption. Registered addressing is highly efficient because registers operate at CPU speed and eliminate memory latency. In contrast, in register indirect addressing, the register does not contain the operand itself. Instead, it stores the address of the operand in memory. Therefore, the processor must access memory once to retrieve the actual data. This increases the memory access count to 1, leading to slightly higher execution time and higher power consumption compared to pure register addressing. In real system, this difference because more efficient because memory access is lower than uh, registered access. Although indirect addressing introduces overhead, it is very useful in implementing pointers, dynamic data structures, linked list and arrays where memory locations change dynamically. So while this addressing offers maximum speed and efficiency, this indirect addressing provides flexibility at the cost of slight performance reduction. And the third, next we can move on to the third code. And this third code explains the displacement addressing. The effective address is calculated using the formula EA is equal to base plus displacement. This requires one arithmetic addition operation and typically one memory access to fetch the operand in the MATLAB stimulation. The execution time is moderate and classified accordingly. In base plus index plus displacement ad- addressing, the effective address is calculated as EA is equal to base plus index plus displacement. And here two operands are required instead of one. However, the number of memory access usually remains one because after computing the final effective address, only one location is accessed to fetch the operand. The important observation is that arithmetic computations inside the CPU is much faster than access. Therefore, even though base plus index plus displacement involves extra operations, the increase in execution time is minimal compared to the delay caused by memory access. The MATLAB tick and talk result may show a slight increase, but it is relatively small. This addressing mode is extremely useful for handling arrays matrix where the base represents the starting address, the index represents the position, and the displacement represents structure offset. In conclusion, the major factor affecting performance is memory access, not arithmetic computation. Adding more address components increase fixability with only minor impact on execution time. Thank you.